Singularity.
My name is Nicola, and you're watching Singularity FM, the place where we interview the future. If you guys enjoyed this podcast, you can show your support by either writing a review on iTunes or by becoming a patron via interviewthefuture.com. Today, my guest on the show is world-renowned cosmologist and astronomer royal, Sir Martin Rees. Martin has also been concerned with the threats stemming from humanity's ever heavier footprint on the global environment and with the runaway consequences of ever more powerful technologies. His latest book, On the Future, Prospects for Humanity, is all about those issues which we are going to be discussing today. So, Sir Martin Rees, welcome to Singularity FM.
Very good to be talking with you.
Thank you so much. And let me start with a sort of a protocol issue or an admission. You see, I have never had a British lord on my podcast before, so I will have to ask you as per how I should address you.
Just call me Martin. Just call me Martin.
Thank you so much, because my podcast is rather informal. It is styled after the sort of ancient Greek Socratic dialogue or conversations. But you're a baron, I think, if I get that right.
Right, yes.
Right. So I just wanted to make sure we don't make a mistake with the protocol here. But thank you, Martin. I really appreciate it. So if I were to ask you, who is Martin Rees? And you were to explain that to someone who's never heard of you and your work before, how would you do that in a sentence or two?
I would say I was someone who'd spent most of my life as a scientist and teacher, specializing in astronomy and space science. But in my later years, I've broadened my interests and I've been working on technological risks and also on issues of the environment because I've been more involved in politics and in administration and had more chance to go beyond my own special subject.
Mm-hmm. That's fantastic. And speaking of getting more involved beyond science into even the politics, perhaps, do you find it helpful that you have a lordship position, either as a sort of being more able to spread your message or being able to directly be able to influence policy?
Well, the fact that I'm a lord means I am a member of Parliament. So that obviously means I have a bit more of a ringside seat, as it were, in terms of politics. And I also have been involved in a lot of scientific politics because I was for 5 years president of the Royal Society, which is the British and Commonwealth Academy of Sciences. And so that obviously gave me a perspective on international science and also on the issues where we are concerned about how we apply our science.
So do you think that the politicians in the UK Parliament heed sort of your advice or your presence on those scientific matters?
Well, of course, on general matters, I don't have any special right to be heard, but I think in the UK, we have a fairly good record of involving scientists in politics and policy. And that's why we have got a better regulation system for embryo research and stem cells and things like that, and why we have taken a lead in climate policy.
Mm-hmm. Mm-hmm. Very well. We're going to come back to that issue in a second, but let me ask you this. You have a very interesting personal journey, starting with, if I get this right, math and economics, then going through something like maybe even political science, and ultimately ending up in astronomy and physics. Is that correct?
Well, not quite. I mean, I studied mathematics and science, and as an undergraduate, I studied mathematics, but I knew I did not really want to be a mathematician. I'd talked to my contemporaries, and I know I didn't have their mindset. I wanted to do something a bit more synthetic and synoptic, as it were. And I did think of switching to economics because I had some good friends who switched to economics, and two of them are now very well-known economists. And so I did think about going to economics, but then by a chain of accidents, I managed to get accepted in a group in Cambridge that was doing research in astronomy and space. And that was a lucky accident, really, because it was one of the best groups in the world. And also, I was starting at a time when new things were happening, the first evidence of the Big Bang, the first ideas about black holes, etc. So it was really a bit of luck that I ended up in astronomy. All I knew at that time was I wanted to do a subject where I could think outside the box, as it were, and not just do very long chains of deductive arguments like a mathematician does.
Mm-hmm. And where do political science and philosophy come about, or do they?
Well, I mean, obviously, a lot of science, especially fundamental science about the micro world and the cosmos, does impinge on philosophy. And obviously, also the application of science involves ethics and politics and economics.
So, did you take any sort of like personal or academic interest from those disciplines? Because one thing that really impressed me in your book, and we're going to talk about that even more later, is how much of sort of like a normative or an ethical perspective you bring in, and also how clearly you say that there is a necessity and a requirement for value system, morality, and ethics to be present within the application of science.
Yes. Mm-hmm. Well, I mean, I think it is clear, but there I speak as a citizen rather than a scientist. But I think, as regards my personal history, I have always been involved in environmental issues. But during the 1980s, I really got quite heavily involved in discussions about arms control. I used to go to meetings of the so-called Pugwash conferences, and I had the privilege of getting to know some of the older generation of physicists who've been involved in Los Alamos and making the first nuclear weapons. And it was a privilege to know these people. And I came to admire them. And I then realized that they set really an example for any scientist who was doing work that had a societal impact. And that when that great generation was no longer with us, then it was up to the younger generation to try and learn from their example. And of course, what's happened since then is that we've had to consider not just the implications of nuclear science to nuclear bombs, but the implications of many other areas of science to biology and environment. And I have become more engaged with these. I can't claim to be an expert, obviously, in most of these areas, but I have been involved in discussions and have tried to emphasize when I am teaching students that they have an obligation to make sure that anything they discover is used to human benefit and that they do what they can to minimize the downsides.
Mm-hmm. Yeah. You see, that's interesting to me because when I interviewed Professor Lawrence Krauss, for example, he told me that ethics has no place among the greatest questions of physics of our day, basically.
Well, I mean, I wonder if he really said something quite as stupid as that. Because
I hope it's all my fault that it sort of paraphrasing it poorly, but we can put the link to the original interview and let people decide for themselves.
you'd agree with it. Obviously, the science itself doesn't have any ethical connotations. You know, the facts about the external world and the way atoms and nuclei behave. That is something which doesn't have any ethical component. But the way you make use of that knowledge, whether you build bombs with it or use it in other ways, that clearly does have ethical implications. So science
And my
itself.
claim was going even a little bit further than that by saying that even deciding what we should do research in, how to prioritize or rank the
Yes,
different alternative scientific pathways, and as you just said,
yes.
ultimately what we end up doing with our discoveries are all ethical questions. Uh,
Well, well, I partly agree, but I think the point is that you can't really predict how a discovery is going to be used before you've made it. And so and any discovery can be used in different ways. Let me give an example, the laser. The laser was invented in about 1960. It made use of basic ideas that Einstein had had 40 years earlier. But the people who invented a laser in the 1960s, they didn't know it could be used both as a weapon and also for eye surgery and also as part of DVD players. So they could predict that. And so when you do the basic science, you really don't know what the implications are. And in most cases, there are some implications which are benign and some which are harmful. And so it's when you get to the stage of deciding which applications to develop, there you should prioritize. But I think the basic physics itself, atomic physics and the periodic table and nuclear physics and all these things, Darwinian evolution, these are all things which are part of our understanding of how the world works, but they don't in themselves have any ethical connotations.
Yeah,
I
my
don't think I'm
example.
disagreeing very much with Lawrence Krauss.
Sorry?
I don't think I'm really disagreeing with Lawrence Krauss.
Okay, okay,
Mm.
interesting. Yeah. My example was mostly the case of people like Fritz Haber, for example, who invented basically how to create artificial fertilizers and
Yes,
also invented mustard gas and all kinds of other chemical
yes,
weapons.
yes.
And I think in those cases it was very clear when you're working on what the implications were.
Yeah, that's right. He should have done one, but not the other. Yes.
Right. And Einstein actually got very disgusted from many of his colleagues in Germany of his day, who basically kind of overnight embraced German extreme nationalism and switched from their sort of academic work to working for the fatherland and in producing weapons of mass destruction.
Yes. Mm. Well, he was right to be disgusted. And the point is that when we apply our science, we ought to bring in morality and ethics and economics. But then, of course, we are not experts. We know some basic facts, but we're not experts in ethics or in economics.
Yes, yes. Uh, Martin, what is your motivation to get out of bed and do what you do? You're 76 years old, you're
Yes.
incredibly active, you speak all over the world, you write books, you participate in events, you're very present. I enjoy the wealth of videos of your presentations online. You have written a number of books, 500 scientific papers. What is the motivation for such a productive work?
Um, well, I'm very fortunate, really, to have worked in a good environment. I've been based much of my life at Cambridge University. I've been able to travel around the world to other academic centres, and I feel very privileged that I've had the chance to participate in debates and discussions which are going to be very important. I haven't made huge individual contributions, but I think the progress of science, particularly in space science and astronomy and cosmology, over the last 40 years when I've been involved, will, when the history books are written, be one of the most exciting chapters. And I'm very lucky that I've had the chance to participate in these developments. And also, I've been fortunate to have the chance to get involved in wider aspects of society by being president of an academy and being involved in politics, etc., and to have the chance to speak and get invited to travel. So I've just got a very fortunate life, and I just feel that so long as I remain sufficiently active, I want to go on doing it.
So, is it fair to say that, to paraphrase what you just said, that your goal has been to ultimately push science forward, to help science progress?
Well, that's my prime goal, but I think now the focus has been to realize that the way science is applied is crucial. I mean, the main theme of my most recent book, On the Future, is that this century is special. The world's been around for 45 million centuries, but this is the first century when one species, the human species, can determine the future of the planet. And that will depend on whether we learn the right lessons from science in environment and climate, for instance, and whether we apply science in good ways and avoid the downsides. So I think it's very important that we should understand science and campaign as much as we can to ensure that it's applied wisely. And that's what I've been trying to do in my recent years.
Fantastic. I'm completely in support of that message because my whole personal work thesis has been for the last 10 years that technology is not enough, that it's necessary, but it's not sufficient. And whether it would do good or bad in the end is ultimately an ethical decision. This is why I'm trying to bring in the sort of the Socratic perspective, if you will, by the Socratic dialectical method of investigation and
Yes.
asking questions and sort of
Mhm.
push forward that we can do more than merely invent things, but also think about how we apply them for the betterment of humanity.
That's right. Yes. Yes. Mhm.
Okay, so what is your greatest fear?
My greatest fear, I think, is that some new technologies, particularly bio and cyber technology, uh, will be misused. And the problem is that, of course, they empower an individual or a small group in a way that was not conceivable in the past, so that they can have an effect that cascades globally. The way I like to put it is that a global village will have its village idiots, and they will have a global range. And this is scary. And I think to avoid this happening, there's going to have to be some tensions between maintaining privacy, security, and liberty. And I do worry that there is a risk of society breaking down if these kinds of disturbances happen too often, because society is very interconnected. We depend on global networks, just-in-time delivery, financial systems, and all that, and they're all rather fragile. So I do worry that there is a growing risk that society could suffer a serious breakdown, which would cascade globally. There's a famous book by Jared Darman, which you may know, on collapse. He
Yeah.
talked about 5 civilizations which had collapsed. But in all those cases, it was just one part of the world. Whereas if we had something like that that happened now, no part of the world would escape. It would be a general setback to civilization. And let's hope this doesn't happen. I'm not saying it's probable, but it's something we need to worry about, which is possible now, but wasn't possible in the past. And I like the mantra that the unfamiliar is not the same as the improbable.
Mm-hmm. Mm-hmm. Very well. So if we were to flip that question upside down, instead of your biggest fear, what's
Yes.
your biggest dream?
Well, of course, the dream is that we can harness science and avoid these downsides and have a world where we have a population of several billion people who can live a life which is better than the life any of us live today, because it won't be like the life we live today, because the world can't support more than 1 billion people living like present-day Americans, eating as much beef and using as much energy. But we can imagine, if science was harnessed ideally, a world of smaller inequalities and where everyone. Sorry, that was my dog knocking over something.
I'm sorry.
Where everyone can live a contented life, and so there's huge promise of technology, but we've got to ensure that the governance is good and we avoid the risks.
Fantastic. We'll come back to that, but to take a little digression, sometimes I want to sort of push my interviewees off balance by asking them if they're a cat or a dog person suddenly out of the blue.
Yes, yes.
In your
Well,
case,
you're a dog
that's
person.
not necessary. We already know you're a dog person.
Yes, yes.
What kind of dog do you have?
It's a black Labrador.
Black Labrador.
Yes,
Fantastic. Those are very smart dogs.
yes. Mm-hmm.
Fantastic. Okay, let's go back on topic though. What is AI in your opinion, and how does it fit within that sort of power play between your fear and your dreams?
Mm. Well, here again, it has the potential to provide huge benefits, but also opens up new risks. In the short run, there's the question of how it will disrupt the labor market, because it, of course, along with robotics, is going to take over certain kinds of work, but not others. And that's a economic and social problem that needs to be dealt with. Again, it can be benign, because it'll take over some jobs. It'll take over unpleasant jobs. like working in an Amazon warehouse, or being in a call center and things like that. It'll certainly take over those. It'll also take over some skilled blue-collar jobs, or at least part of them, being doing legal work, computer coding, medical diagnosis, and things like that. But it won't take over some jobs like being a plumber, or being a gardener, because they're so non-routine, they're very hard to mechanize. So certainly the labor market will have massive shifts. And I think one of the issues we have to cope with, and this is in the short term, is to ensure that there is fulfilling work available for the people whose jobs are displaced by robots or AI. And I think this is going to require a bit of socialist redistribution of wealth, but this should be used in order to set up a very large number of jobs where the human element is crucial. I'm thinking particularly of carers for old people, assistants to teachers in schools, custodians in public parks, and things of that kind, where certainly in my country there are far too few, and they're far too badly paid and not respected enough. So I think the ideal way in which these techniques can be used is to displace people from jobs like Amazon warehouses and call centers, and to give them more satisfying work of a kind where a human being can't be adequately replaced by a machine. So I think that's a short-term one. But of course, in the longer term, then there are these questions of the extent to which machines will acquire human capabilities. They clearly will in some ways, because we've had for 50 years machines that can do arithmetic better than a human being, right back from the first pocket calculators. And we now have machines that can play chess and Go better than a human being. The AlphaGo Zero learned within 3 hours how to play chess and Go as well as a world champion. And this is a huge capability. And this is going to be something which could be misused, but I think offers huge benefits. I mean, for instance, it would allow China to have a planned economy of a kind that Marx could only have dreamt of, because it can gather all the information about all financial transactions. The Chinese already gather 80% of those transactions, and it would know all about the stocks in shops and in factories. And so all the things which the Soviet Union couldn't do, because it didn't have the information, could be done by AI, which has the speed and the calculating capacity to manage something as complicated as an economy. And certainly, if one doesn't want to do that, it can manage traffic networks, electricity grids, and things like that better than any human being can.
And what about astronomy? Are there computers already, or will there be computers soon that can better identify stars, galaxies, planets than actually human astronomers? How would the job of an astronomer be impacted?
Well, there are some things which they can do much faster, because it's true that to identify images on a photographic plate or something like that is a skilled job. And it is now true that computers can do this at least as well as a trained human being. But the important thing is that they can do that sort of job thousands of times faster. So now in astronomy, we have big data. There's a European project which has provided data on 2 billion stars. And that cannot be done by individual astronomers going through these stars one by one. It's done by machine learning and computing. So that's one example. And the other thing which computers can do is to do computer simulations of the flow of gas around a black hole and things like that, which is the same sort of thing as is done in weather forecasting, but this is done for cosmic fluids, and this has been very helpful to us. So I think computers clearly are crucially important for analyzing data and for modeling what we do out there, because we can't do experiments on galaxies, but we can only do virtual experiments in the world of our computer, and we can simulate what would happen. So that's great. And of course, if we think of space, then one exciting technology that I follow very closely is space technology. And there again, um, robots can do things better than human beings. And already we've had a picture sent back from all the solar system, even from Pluto and further away, and that's 20,000 times further away than the moon. And we can do much better now because those probes were designed in the 1990s. And think how much better we can do today. Uh, think of the advance in smartphones, and that technology can be used in space. So I think that we'll have very advanced space probes to study the entire solar system, to get sharper pictures of distant galaxies and stars. And also, we will have very large robotic fabricators up in space, which can build big structures, large solar energy collectors, and huge telescopes under zero G. So this will be done. The question people then ask is, what's the role of human beings in space? And of course, we all know it's 50 years ago, men landed on the moon, and that's not been repeated. Since that time, people have only gone into low Earth orbits. But the fact is that the men on the moon, the Apollo project, was done at huge expense as a national prestige project. And the budget was cut back once the Americans had beaten the Russians to the moon, etc. Otherwise, there'd be footprints on Mars by now. But I think the case for sending people into space is getting weaker now that robots can do the job better and much more cheaply. So my personal view is that manned spaceflight is really just a adventure for the kind of people who do hang gliding in Yosemite or go around the world in a balloon or things of that kind. People of that mindset. And they're prepared to take much higher risks than NASA can impose on civilians who are funded by a taxpayer. And so that's why I think that the future of manned spaceflight lies with the private companies like SpaceX and Blue
The
Origin.
Elon Musk's and
Elon Musk,
Patrick Branson's.
Yep, yeah, yes, and Jeff Bezos's Blue Origin,
Yeah.
Because they can take higher risks than NASA could with the space shuttle, which failed twice in 135 launches, but each failure was disaster. And these private companies can launch into space the kind of people who are happy to take a big risk. And we know there are such people. Some will be happy to go with a one-way ticket. And so I think that's the future. And incidentally, Branson is making a mistake talking about space tourism, because that implies it's routine. They should use the phrase space adventure, because if they call it space tourism, then the first crashes will then cause a trauma. Whereas if they are billed as a dangerous adventure, then of course we react with sympathy to brave people losing their lives, but we will think that's the way they wanted to go.
Mm-hmm, mm-hmm. I understand. Which is why you said that sort of mass level sort of manned space exploration is delusional and dangerous.
Yes, I think so. And here I disagree with Elon Musk and my late colleague Stephen Hawking, because I think it would be very, very hard to make Mars as comfortable as living at the South Pole. And so I think Mars will just be a place for adventurers. But good luck to them, because there's a reason why we should cheer them on, which is that when they get to Mars, they'll, of course, be badly adapted to it. The atmosphere isn't right, different gravity, etc. And so what they will do is use all the techniques of genetic modification and cyborg techniques to link themselves to electronic brains, and they will do all that, and they'll be away from the regulators, because here on Earth, we don't have the motive because we're quite well adapted to living here on the Earth, but also I think we're going to have to regulate all these techniques. But they're away from the regulators, and so I think their progeny will soon become a new species. And I think if we think of the far future, then there'll be a new kind of evolution, which is not Darwinian evolution, but it's a sort of secular type of intelligent design. which would be these machines designing themselves and adapting themselves. And this will happen much, much faster than Darwinian selection did. So it's taken about 1 million years for humans to evolve, but within just a few hundred years, there may be creatures living out in space which are very different indeed from us. The post-human era will start there.
How would you define artificial intelligence? Because you see, I've interviewed 230 people on my podcast, and one thing that I've noticed is that many have slightly, or even in some cases, greatly different interpretation as per what AI actually means. So I want to make sure we're clear about what we're talking about.
Yes. Well, I think it is rather vague. I think there are some problems where the machine just works very fast and helps and learns by itself. And to take an example, the best way you get machine translation now is to let the machine go through millions of pages of multilingual text. In fact, in Europe, they take European Union text. It's very boring, but they don't mind getting bored. And so there they have the advantage of speed. But I think some people are concerned that AI will get a bit beyond that, because already the machines that learn to play Go, for instance, a very complicated Chinese game, they learned the game and they made moves which surprised even the best players. So it looks as though they're thinking differently and in some sense better than the best human player. And the humans who are watching the games don't really understand the sort of thinking processes of these machines. They don't understand what they're doing. And so this is really something which is a game changer, in that the machines are doing something which is superhuman in a sense, and humans can't quite understand why they're doing it. Now, of course, the one thing that machines aren't very good at yet is interacting with the external world as adeptly as a child who can move the pieces on a real chessboard, or even a monkey that jumps from tree to tree. We can't make robots can do that. But if at some stage one can combine the speed of thought of the machines that play Go and chess with human abilities to interact with the environment and to move around and behave in a more graceful way, and not just the way that present-day robots do, then of course there will be the question of whether these entities are things which we should treat as beings that have rights in the way that animals do, because we certainly feel that other humans and even some animal species have rights in a sense, and we have obligations that they shouldn't be underemployed or bored. And perhaps we should have that attitude towards these robots if they eventually have human capabilities and seem to be like us. But of course, the fundamental philosophical question of, are they conscious? That's still open. That's a very deep question. And whether they are zombies or whether they are actually conscious in the sense of having an inner life as we do.
Well, what's your take on the Penrose-Hameroff OR theory of consciousness? And I believe Sir Roger Penrose is one of your colleagues, isn't
he? Indeed, he is. Yes. I mean, I would say I don't particularly buy that, but I'm not an expert, so I don't want to say much about that. But I think the mechanism of consciousness is a very deep mystery. Some people, of course, say it doesn't really matter, because if you have something which behaves as though it's conscious, then whether it's a zombie or not doesn't matter. But I think there's one context where it matters a lot, and that's if we think of the far future and imagine that we've been, in a sense, superseded by electronic brains of some kind, robots, which could start on Mars, but they could spread through the galaxy because they'd be immortal, and that they can spread further. And I think our attitude towards that scenario will depend very much on whether we think that they are, in a sense, better than us in that they think more deeply and have deeper feelings, or whether they're just zombies. If they are just zombies, then I think we would view with disfavor that long-term future, because there'd be no consciousness to really appreciate the wonder and mystery of the universe. Whereas if they are able to do that, then of course we should welcome their takeover. So I think it does make a difference whether consciousness is an emergent property in any sufficiently complex system, or whether it's something which is peculiar to the kind of wet hardware that we have in our skulls.
But
And
let's
that's an open
presume that
question.
they do have consciousness, though. Why should we welcome their taking over of us? Because that would basically effectively mean the end of the human species, wouldn't it? And why should we welcome that of all
Well, I
things?
mean, I suppose we're entitled to be a bit chauvinistic, but I think this will happen way away from the Earth. My scenario is that on the Earth we won't have such rapid changes. We'll regulate these so human beings a few centuries from now hopefully aren't too different, but there will be these entities in space, and I think they could develop in a time scale of centuries. And um, I, they would not necessarily take over from us, we'd still be there, but they would be, in some sense, more advanced than us. And I think as an astronomer, I push this further, because the one thing we know in astronomy is that although it's taken 4 billion years for us to evolve from the first life on the young Earth, the time lying ahead is even longer. The sun has 6 billion years more before its fuel runs out. And so in that time span, there could be huge evolution, especially as it's going to be faster than Darwinian evolution. And so we are not even the halfway stage in the emergence of complexity in the cosmos. An important transition, I think, because it's up to us this century whether we facilitate this transition or whether we foreclose it by screwing up completely here on the Earth this century.
Right, we're going to come back to that in a second, but I want to exhaust a few other questions before that. And the reason why I ask you to define the what artificial intelligence means for you is also because I want to bring in the concept of the technological singularity and have the distinction between the two of those. Can you speak about the AI and then the singularity and your take on those two?
Yes. Well, the singularity is the concept that machines will take over, and then they'll develop even better ones, and there'll be some sort of runaway. I don't find this a credible idea at all, because it's true that some things can happen faster and faster, but actually manipulating large amounts of material on the Earth's surface can't be done at that sort of speed. And also the interaction with the real world of a computer is going to be constrained by the ordinary laws of physics, just like our engineering projects are. So the idea that there'll be some particular time when everything becomes different and the Earth is reassembled into something else, I think that's very unlikely. But I do think that there's likely to be a growing range of activities where humans are surpassed by something that's inorganic.
So basically, you're saying at the very least that it's very unlikely for us to have what's called a hard takeoff of the singularity, but
Yes.
maybe not impossible to have a long-term softer takeoff?
Well, right. Yes. Yes.
I see. And what's
But I
your
think
sort?
that may happen away from the Earth.
Right, yes, for the
Mm.
reasons that you mentioned
Yes.
before.
Yes.
And how do you see the timeline to any such possibility, perhaps? 20 years, because there's all kinds of projections here. People have said
I
Ray
know.
Kurzweil has given 2045, for example, most famously.
That's right. And Rodney Brooks has said never. Yeah, yeah. So there's a big range. Um, and so I don't. I wouldn't put a time span, but I think it won't happen all that fast here on Earth, but I think it will happen once we have a self-sustaining group that's away living on Mars, because they want to adjust themselves, and if they become immortal, then they won't be deterred from interstellar voyages, and so that's the way our descendants could, as it were, spread through the galaxy. So I think that's a possibility, but it'll be a time scale which is short compared to cosmic timescales, but probably long compared to human timescales.
Very interesting. Okay, so let's move and talk a little bit more about your books. And first, before we talk about your latest book, I just want to touch up on the book before that, I think, which was called Our Last Century.
Yes.
And you actually mentioned already during our previous conversation that we live in a very crucial century.
Yes.
And the usual kind of response that people tend to give to that often is that historically speaking, every generation thinks and believes or are biased to believe that they are indeed living in the sort of crucial century,
Yes.
as well as believing often, if not always, that the next generation is doomed and is like failing in all kinds of ways, and
Yes.
the world is going to the dogs, as one of the ancient Greek philosophers
Yes.
put it.
Yes.
So
Yes.
why is it different this time?
Well, I think there is a definite reason because, first of all, the human population is much, much greater. It's 7.7 billion now, and they're all more demanding of energy and resources. So, this is the first century where humans have been having an impact on the planet collectively, on its the biosphere, the land use, and all that. You'd see that difference if you observe from space. So it's the first century um, when our species has been numerous and empowered enough to really have an impact on the planet that you would observe from space. And you'd also observe radio emissions coming out and projectiles leaving the Earth, going into space, etc. So it is a special century, and it may be a transition to something better, or it may not be. But that was the reason for saying it is special, because quite apart from the more obvious things that it's much more interconnected and we have more technology, it's clear that we are collectively having an impact on the environment and on the non-human environment.
Okay, so let's talk about on the future.
Yes.
And if you were to give sort of an estimate about the prospects for humanity,
Yes.
whether we're going to make it through this century or not, what's your kind of number? Because I've been shocked to have guests on my show who have given as low as 2% chance for humanity. Others have been a lot more optimistic and have said,
Yes.
well, we're more likely than not, and others have gone as high as 75 or 80%.
Yes.
Whereabouts do you stand on that?
Well, I mean, I think it's unlikely we'll wipe ourselves out completely, but I think I would still, as I did in my first book, which you mentioned, A Final Century, say there's a 50% chance of a severe setback to civilization due to either not handling environmental crises or breakdown in society due to misuse of bio and cyber. So 50%, I would say. I don't know whether you call it optimistic or pessimistic compared to most people, but that's what I would say.
I've had some guests who told me that people who give a 50% chance of something basically say, I don't know.
Well, of course, there's one doesn't know very well, but you can envisage various scenarios, which I discuss in my book. But the way they would couple together, we don't know, because for instance, if you have a pandemic, that will cause social breakdown, and that might cause starvation, etc. So we just don't know how they would link together. But it's not too difficult to imagine scenarios which would be a setback to civilization.
And you actually have a $200 bet with Steven Pinker about that, don't you?
Well, that's rather different. That's a slightly more limited one about whether 1 million people will be killed by within the next 3 or 4 years by some bio error or bioterror.
Mm-hmm.
That's a
So,
separate one.
so tell us a little more about that bet, please.
Well, it's just as I said, and I fervently hope to lose it, of course.
And
But,
when's the deadline for that to
I think it's about three years away.
uh-huh.
I
I
think,
see.
um, but because in fact, I first made this sort of bet when I wrote my earlier book, which was 15 years ago,
Hmm.
um, and it's simply that we know that it's possible to make viruses more virulent and more transmissible, and there could be some sort of error. So I hope I'm wrong, but I think it's not absurd to feel that there could be some disaster of that kind.
Hmm.
And
You
Steven Pinker's, of course, um, he's very optimistic about nearly everything.
yeah,
Well, I mean, just to digress, I mean, I think he's everything that he says in his book is right about the respect in which we are better off in terms of life expectancy and etc. Than our forebears. So he's completely right that this is a better time to be alive. But what he doesn't take into account is that there's a new class of threats which didn't exist in the past, and their character is that they are very asymmetric. Um, uh, there's a small chance of something really bad happening, and we can be lulled in security by the fact that nothing like this has happened, but the probability is going up, and one event will be too many. And so there are these new classes of threats, which are what I worry about and what I talk about in my book, which I think have to be put in a balance against all the obvious positive trends, which are the theme of Stephen's book.
hmm And you make another very important point, I think, in discussing Steven Pinker's work, and that's the fact that, a couple hundred years ago, we didn't possess the capability to feed everyone or to give vaccines to everyone or to do a
Mm-hmm.
number of other things which we can easily do today, and
Yes.
yet it doesn't seem to be happening as much or as often or everywhere that it should happen. So therefore, today, despite all the progress that we've made, actually, compared to our capabilities, we haven't gone far enough. We haven't done as much as we should have done and should be doing. And so that's kind of a more of a normative take on the facts rather than just looking at them.
Yes, that's right. So I would, for just that reason that you've explained, question the idea that there's been much ethical progress, because the gap between the way the world is and the way the world could be
Yes,
is
and do
wider
you think
than it
that
was
gap
before.
is growing actually?
I don't know. It's distressingly wide, because we know that, as I say, the richest people on the planet could just by themselves make a big difference to the lives of the bottom billion people, mainly in Africa. And so the fact that we tolerate these huge inequalities is an indictment of the global ethical standards. And so that's why I'm doubtful that we are more humane in general. Obviously, in some respects, we are. We don't have public execution and things like that. But I think if we were to actually consider the overall balance of what could be done and what is done, then I think there is a widening gap.
And one thing about on the topic of what could be done
Yes,
is we mentioned previously the issue that we're both concerned about of technological unemployment. And
yes.
you are talking, if I can quote you, of a socialist redistribution. Is that a correct?
Well, I mean, to social, well, massive redistribution, which involves very high taxation and probably welfare state. It could be done by the private sector, but uh, by financial incentives of various kinds. But I think this could be more easily done in a socialist economy.
Mhm. So, so is that a way of you saying that it should be done, that we should be doing this?
We should certainly be doing this, yes, because I think it's appalling that we don't have decent jobs for carers for old people, and are far too few to provide the care for the average old person, which a rich person would buy for him or herself. And so I think the one of the worst things of our society is the lack of that sort of care, and that could be provided. by taxation, especially if the jobs now done by fairly unskilled people are the jobs that will be mechanized.
And you're also suggesting this is a way to ameliorate or alleviate the issues related of from arising from technological unemployment. So this is where we can create jobs and sort of have people have income and so on.
Yes, and to amplify that a bit, it's always said that it's the unskilled jobs which will be those where the uh, machines take over first, and that's true. But the people doing the unskilled jobs, they don't have technical ability, but they, in many cases, have more human qualities, which is what is needed to look after an old person.
Yeah.
So, if you're old and sick and you want some old carer, then you're just likely to find that person among those who are now in call centers or Amazon warehouses, as among someone who's a computer geek. And so this is a win-win situation because if the money that's now um, paid to people doing these rather nasty routine jobs um, is their jobs are taken over by machines, and then the money is recycled to pay for these jobs as carers, then that would be better for everyone.
Mm-hmm.
That's the kind of thing I'd like to see.
Yes, and one other implication of that or element of that suggestion of yours is the fact that you believe that this kind of a subsidizing of job creation in particular fields is a better way of resolving technological unemployment than universal basic income, for example.
First of all, there are these jobs to be done, and I think people who are capable of doing a job should do something in return for their pay. But of course, we ought to be generous to those who are unable to work because they're sick or old, and disadvantaged in other ways. But I think the basic income it's rather inefficient, and also I think most people prefer to feel they're making a contribution, and having work is something which gives people a kind of dignity, and the kind of jobs which we could replicate in large numbers are jobs that certainly ought to give people satisfaction. Looking after a disabled child or something like that, that's a satisfying job. And certainly in most countries, it's very sad that there are so few people who are able to do that sort of work.
Mm-hmm. Mm-hmm.
Well, and the few that are not properly paid.
I see.
So I think it's quite possible to redistribute the money that's earned by the robots to create jobs of this kind.
Mm-hmm. Well, we discussed one of the shorter or mid-term sort of problems on the horizon, but what, in your opinion, are the big issues, the big crisis points that humanity would be uh, challenged by in this 21st century?
Well, I mean, I think to make the transition to a carbon-free economy, because it's clear that by the end of a century, there's a severe risk of really drastic climate change if we don't cut down CO2 emissions. So that's one thing we've got to do. And I think we have to ensure that technology is applied in a way that benefits people in what are now the less developed parts of the world, like Africa. And I say that not only because it's ethical that should happen, but it's in everyone's interest, because if you look at Africa now, they are in many cases very, very poor indeed. They don't have sanitation and things like that, but they do have mobile phones.
Yeah.
So you know what they're missing. And I think if their lot is not improved, then we can expect massive disaffection, mega versions of the uh, motions of uh, migrants across the Mediterranean, mega versions of the boat people now coming to Europe from
Mm-hmm.
Syria, and in order to stop that, then we in the wealthier countries of Europe and North America need to ensure that Africa does get out of poverty, and not just for altruistic reasons. It's in our interest too. And so I would say that that's the big challenge, to ensure that Africa doesn't get left behind.
Mm-hmm. Mm-hmm. And what about? I know you have a strong interest in existential threats. What are the top 3 existential threats that we're facing?
Well, if by existential you mean wiping everyone out, I think they're all very unlikely. But what I worry about are the kind of threats that will be a sort of setback to the progress of civilization,
Okay.
maybe even an irreversible one, so that
Okay.
humans don't get wiped out, but they revert to a more backward state.
Okay.
Um,
So which ones are those threats then?
and this would sort of foreclose the bright options which one can foresee if things go well in this century.
Mm-hmm. So what would those be? Would that be like climate change, nuclear weapons, or AI, or what?
Yes, well, as a climate change, it's not existential. It won't wipe everyone out, okay? But it can be a setback to civilization. And the other thing that could happen is a sort of growing anarchy. If we have a situation when a few people can make dangerous bioweapons, a few people can create cyber attacks that can't be countered, and all that, then that would destroy the fabric of society. And so that's another possible threat.
Well, some people have said that AI is an existential threat because it could wipe out everyone.
Um,
And some
but
of those people have been physicists too, by the way.
yes, I mean, I don't quite see how that could happen unless it found some way to blow up the Earth.
Mm-hmm. Okay, well, others have pointed out that our old estimates of the impact of a possible nuclear war have been greatly underestimated, and there were new estimates done in the last 10 or 20 years that sort of corrected by an order of magnitude perhaps the impact that we had in the 70s and the 80s. Is that correct in your view? Because some have said that a nuclear war, and now with the situation between, let's say, Putin's Russia and the West, or even India and Pakistan and other places, I mean, the Middle East, Israel, we have North Korea, the number of nuclear armed countries is growing. I think we have about 9 today. So what about that? Is that not an existential threat?
Um, well, not quite existential in the literal sense, but I think the biggest threat we were under was, of course, during the Cold War, when there were at least 60,000 weapons on each side. And we could have stumbled towards Armageddon by some kind of miscalculation. And if one looks at the record of the false alarms and the view of people like Kennedy and McNamara at the time of the Cuba crisis, it's clear that we were quite lucky. And in fact, Kennedy said the chances were between 1 in 3 and evens. And McNamara said that they escaped a nuclear war through luck more than anything else. And I think that's very scary because I remember that period. And I think that if people had really known how high the risk was of a nuclear war, they would not have supported the policy. And I personally would not have supported nuclear deterrence if there was a 1 in 3 or even 1 in 6 chance of a nuclear war, even if the alternative was a certain takeover of Western Europe by Russia.
Yeah.
That would have been preferable to a 1 in 6 chance of destroying the fabric of Europe. And I don't think people realized just how great the risk was. So, and that risk is in abeyance because the number of nuclear weapons is much less.
Yeah.
It could be a regional conflict and fewer there. But of course, there could be a new standoff between perhaps new superpowers, which could be on the same scale as the Cold War was, and perhaps handled less luckily. So that hasn't gone away. And the issue of nuclear winter, this is something which could aggravate even a regional nuclear war, but it depends crucially on how much fire is released, because the nuclear winter depends on lots of dust and smoke getting into the upper atmosphere, and this depends. And I would say that although the worst case is even more catastrophic than people thought, it could be overstated, because, for instance, at the time of the Iraq War, some people said that setting fire to some of the oil oil wells could cause that problem, and it didn't. So I think these bad things could happen, but I worry more about new classes of threats from biology and cyber, because there was a report produced by the American Defense Department in 2012 when they talked about a cyber attack on the electric grid in the eastern US, and they said this would merit a nuclear response. And of course, it probably would, because if the electricity grid was shut down for more than a week or two, then there'd be complete social breakdown. The lights going out is the least of one's problems. You get no computers work, and etc., and supply chains break down. So the fact that a few people can create that sort of catastrophe means that we are vulnerable to new classes of threats which didn't exist in the past. And although I worry about a resurgence of something like the Cold War, I worry more about these more disorganized types of anarchy.
Mm-hmm. Towards the end of your book, you talk about the limits of science.
Yes.
So can you tell us just perhaps a little bit to unpack sort of, are there limits to science, and are those the limits of our intelligence?
Well, I think it's the latter. I mean, I think science, by definition, is trying to understand the external world. But I think there are limits set by our intelligence to what we can actually understand. And the question is where we will reach those limits. Will it be in string theory? Will it be understanding the brain, etc.? But I think it's a possibility that there will be some limits, or there may be also some phenomena that we are just not aware of, which are important for nature, some new forces or something like that. But I think it's certainly possible that there are phenomena we won't understand. But here, actually, going back to AI, I think AI can help. I said that computer simulations can help us to understand and predict the weather and things of that kind. But I mean, if we take string theory, this is a theory that on the tiny, tiny scale, a trillion times smaller than an atom, space has a grainy structure. What we call a point is a wound up origami in 5 dimensions, and there are many billions of ways in which this can happen. And lots of theorists are working on this, and it could be that there is a version of string theory which is correct, but it's just too complicated for humans to work out. And here the machines may help, because you can imagine that just as a machine could learn to play a game, it could learn to handle 10-dimensional geometry, which is what's important in string theory, better than any human can. So there's certainly, I think, going to be a limit to what human brains can really comprehend. And to some extent, that may be aided by AI. So the 3 possibilities. One is we will have a theory to understand the micro world and the basic forces of nature, which people are seeking. Maybe string theory, maybe something else. We may have such a theory, or it may not exist. But intermediate between those two is the possibility that there is a theory, and we will be able to learn that it's correct by letting a machine do the calculations. But we never actually have an insight into how it works exactly.
Right, and specifically on string field theory, if I remember correctly, Lawrence Krauss again said that there's not a speck of evidence or something, and that he wouldn't even call that science or something to that effect. That it was so kind of divorced from any evidential or experimental science, that it wouldn't even fit within the proper definition of science, in his opinion.
No, I think he's very unfair indeed when he says that, because it's true that we haven't made progress. We've got no evidence that any string theory is correct, but it's a hugely challenging problem, because the one thing everyone agrees on is that any unified theory is going to involve these structures, which are what's called the Planck scale, which is a trillion times smaller than an atom. And so the chance of direct measurements is very small. And it's fairly clear that in all these theories, it involves very complicated geometry. So I think when we bear in mind that it's taken sort of 30, 50 years to verify the existence of the Higgs particle, then it may take far more than 50 years to get any evidence that string theory is correct.
Mm-hmm.
And of course, it may not be correct. It's a huge challenge. It's far away from anything that we can directly measure. So you'd only get evidence for it if we can calculate the long chain which leads from something on that tiny scale to something we can actually measure. And it's a much bigger gulf to be bridged than has happened in particle physics up till now. I think I'm pessimistic about much progress coming, but that's because it's inherently very difficult. But I think we should cheer on the people who work in this theory.
Mm-hmm.
If people don't try, they certainly won't succeed. I do think that perhaps rather too many people are doing it, because if you're going to do science and make a career in science, you've got to
make progress.
Well, you've got to multiply the importance of the problem by your probability of solving it and maximize that product.
Uh-huh.
Don't work on a trivial problem, but on the other hand, if you work on a very deep problem, you've got to feel you stand some chance of making progress. And I think probably too many people are working on string theory, and they'd be more satisfied. But I certainly very much disagree with those people who deride it and say it's not science. It's certainly science to understand, just as much science as atomic theory was, which for centuries had no confirmation.
Mm-hmm. Well, speaking of that and connecting it to the topic of the limits of science, I interviewed Michio Kaku, and he was telling me that his goal for his work is to come up with a single equation that fits, like, that's as long as Einstein's equation, ideally,
Yes.
that explains everything, including love.
Yes. Mm-hmm.
Do you think that's possible? And is there not the limit of science somewhere there, perhaps, that maybe there is no such equation, let alone an equation that would explain love?
Oh, yes. Yes, I think that's nonsense to believe that, because we may not be able to write down a single equation that explains the basic laws of physics on the atomic scale. But of course, even when we've got that theory, if we ever did, it still would only be the first step, because it would not account for the manifestation. I mean, there's a nice analogy, I think, given by Feynman and others, which is that what the physicist is trying to do is rather like someone who's watching chess being played and tries to figure out what the rules are. And of course, that's something which you probably could do by watching games of chess. Okay, but in chess, understanding what the rules are is just a trivial preliminary to the progress from being a novice to being grandmaster. And similarly, even if we did have a theory of fundamental physics, then understanding how that theory manifests itself in complex living things, for instance, is a big challenge. And incidentally, that theory is going to be irrelevant, because the reason that biology is so difficult is because even the smallest insect has layer upon layer of structure. It's very complicated. The people who work on trying to understand insects or bacteria, they're held up by the complexity. they're not held up at all by not understanding subnuclear physics. So that's why the term theory of everything is a very inappropriate term, because what's called the theory of everything is a theory of the fundamental laws of nature, linking gravity and the strong and weak interactions together. And that's a perfectly good definition, but it's not really relevant to explaining things. We don't need to go down to the atomic level to explain many things. I think so. I think understanding the brain is going to be the biggest challenge.
Yeah. A few people have criticized Dr. Stephen Hawking for sort of overhyping or overselling the idea of a theory of everything.
Yes.
Because it's a theory of something, okay, and it's very important and it's very grand and it's very cosmic, but it's not really everything.
No.
Yeah.
No, it's the basic rules of the basic rules governing nature, but the way those rules manifest themselves is the biggest challenge, and that's why if you look at what scientists are doing, less than 1% are doing either cosmology or particle physics. The other 99% are working on ordinary scales, and they're challenged by the complexity.
Mm-hmm. Mm-hmm. Martin, we've been talking for about 64 minutes or so.
Yes.
Would it be possible for me to keep you for another 20 minutes or so? I have a few other questions from the audience that I would like to ask if possible.
Yes. Okay. Yep.
Okay, and before that, let me just bring in another sort of line, because you mentioned your sort of passing interest in economics, and there are people who have made the argument, for example, my previous interviewee was Douglas Rushkoff and a bunch of others, who have said that climate change and a number of the issues that we're facing today are a direct result, even issues like privacy and Facebook and Cambridge Analytica and all of that are a direct result of either what was previously called capitalism, with its sort of like necessity for endless growth and resource exploitation, or what's now been called by others surveillance capitalism, which kind of monetizes, appropriates and monetizes personal data points and so on. So to what degree can we blame, for example, capitalism in general for the problems like climate change, in your view, and the fact that, or at least the claim that unless and until we actually shift and change the underlying economic paradigm, within the current paradigm, we are not going to be able to resolve that kind of problem of sort of negative externalities and pollution and so on.
Yes. Well, I think they're two separate things. I mean, it's certainly true that capitalism has changed because the main assets of the world's biggest companies now aren't huge physical plant, like for the oil companies, etc. They're really sort of intellectual property. And they employ certain people, but it's mainly intellectual property, and that
but it's our intellectual property in a way.
It is part of it. But I mean, they're software as well. Okay,
sure,
which is valuable.
Sure.
But that therefore means that the big companies themselves are a bit more fragile, because you could imagine them disappearing quite quickly if something went badly wrong, whereas you can't imagine ExxonMobil disappearing quite so quickly because it's got these physical plants.
Actually, I personally can imagine, and correct me if I'm wrong, but let's say if we have a paradigm shift to solar energy, Exxon would disappear much quicker than Google or Facebook.
Yes, well, I hope you're right, but I think that'll happen on a 20-year timescale. Whereas, in principle, you could imagine these companies where they're essentially software and IP, that they could be replaced much more quickly. So that's a sense where the nature of valuable capital is different
But
in
not really, because you see, Google is not a software and IP company. Google is a software is a holding company, which is now Alphabet. And so
yes,
whatever they can't innovate anymore, now they're buying. I visited
yes,
Google in 2011. At the time, they were buying two and a half on average, two and a half companies per week. By now, I think they have a portfolio of over 1,200 companies.
yes, yes,
And so they're in a position where they can simply buy out everybody.
yes,
So,
yes.
so I honestly don't
No,
see
that's
them
right. Yes,
disappearing
yes,
very
yes.
easily.
Yes, yes. Well, I mean, I think that there is a problem there of controlling large companies because they can't be taxed properly because they're not in any particular um, country or legal system, so they're not being taxed. And this is, I think, relates to what I said earlier, that there's got to be some way in which one can tax companies like that in order to redistribute the wealth properly.
Hmm.
I think I agree to some extent of what you're saying uh, about the need to think of this new kind of capitalism differently. But then, of course, when we talk about climate change, etc., I think that's different because that's real resources, um, uh, heavy industry, etc. But I think the issue for climate change, which I address a bit in my book on the future, is that um, in order to cope with it, you've got to apply a long time horizon and a small discount rate because we know that um, although climate change is happening now, it won't be a complete disaster in the next 10 or 20 years, although on some scenarios it could be a complete irreversible disaster by the end of a century. And so the question is, can we have an economic system which incentivizes people to pay an insurance premium now
Hmm.
to remove a risk from people at the end of a century, and babies born now will be alive in the 22nd century. And I quote as an example in my book, Bohr Lomborg, the Danish campaigners, Copenhagen Consensus of Nobel Prize winning economists. And they downplay the importance of dealing with climate change, but that's because they take a standard discount rate, as you would if you were deciding where to put up an office building or something. And you
Right.
then um, discount anything beyond 2050 almost to zero. And most of us would feel, and indeed public policy um, in many countries like ours is based on the idea that that's not the right methodology and that we need to apply a low discount rate so that we are prepared to make an investment now to remove a risk from people up to 100 years from now. And of course, that's the basis of uh, public policy in some countries which are trying to have a carbon tax or things of that kind, or to incentivize development of clean energy. So I think it's true we need some new economic thinking. In
Oscar
order
Wilde, that consensus, the Copenhagen consensus, reminds me to a quote by Oscar Wilde, who said that we know the price of everything and the value of nothing.
yes,
And I think economists often really first often measure the wrong things. And
yes,
secondly, the value that they assign to those things is at the very least highly arbitrary, if
mm,
not greatly undervalued.
well,
Um,
yeah,
so
mm,
I personally am highly biased against that kind of future discounting that
yes,
they have a standard practice of applying, unfortunately,
yes,
in economics. But
yes,
let me ask you, yeah, go
yes.
ahead.
No, go ahead. No,
Let me ask you a couple of audience questions here. So, and one of them is coming from a sort of a typical singularitarian perspective, because I have lots of singularitarians who
yes,
listen to
yes,
my show. And of
yes,
course, one of the features of all of us singularitarians is that most of us want to live forever.
yes,
So he says, JD says, I'm working on a book on immortality and trying to figure out a survival plan for the decline of the universe. Considering that the stars in the known universe are estimated to disappear in a few billion years, our only chance to stay alive if we don't figure out how to create new stars by then will be to get our energy from black holes. If
yes,
we have the technology to do it,
yes,
we could preserve our existence for a Google years.
Yes.
which in practical terms is an eternity. I
Mm.
wonder what Martin thinks about the possibility of future civilizations to harness energy from stars and black holes in order to accomplish that. What is that? Your take? I see you're kind of
Well, I mean,
smiling.
I think that is clearly possible, but I think people make a mistake by conflating different timescales. I mean, I've often seen books where people talk about the life cycle of the sun, and they say, we will be watching the sun flare up and die 6 billion years from now. Okay.
From the restaurant at the end of the
But
universe.
yes, but it won't be us. I mean, any entities which witness the death of the sun will be as different from us as we are from protozoa or slime mold, because the time scale in the future is far greater. And similarly, the evolution in the future will lead to things that we can't imagine, um, quite different from us. So I think the idea of extending our lives, people may want to extend them by another 100 years or so, but the idea of extending our lives into a world when we can't understand anything, that doesn't make any sense at all, I don't think.
I think it's coming from the sort of Ray Kurzweilian point of view, where the
Yes.
idea is that if you live long enough, you would live forever, because you would get these bridges, and then
Yep.
you would basically able to ride the longevity escape velocity
Yeah. Yeah. No.
indefinitely.
I understand the argument. I mean, but I think it's it's possible, but there's a limit. But they're talking about a few centuries at most, and remember that that's just an instant compared to biological evolution. And
Well, I interviewed the Frank J. Tipler, and he was talking at the cosmic scale. And not
yes,
only that, but he told me that the singularity was absolutely inevitable. And when I kind of tried to be skeptical, he told me that the reason why I had such an attitude was because I didn't understand the laws of physics, and he did. So that's why he knew that the singularity is inevitable.
um, well, I mean, I think he said the best singularity you get is in a collapsing universe. Did he tell you that? Because that's one thing he believes.
No, but I forget because it's been a few years since I interviewed him,
Yeah,
but
yes, yes,
basically it was a very Christian idea of the singularity in a
yes,
way.
yes, yes. Well, I don't think anyone would agree with him really on that. He's got some very strange ideas. But I think going back to life extension, obviously we know that there's a lot of effort going on now, and of course, if the it's healthy life extended is fine. But and of course, there's the cryonics, the people who are frozen in liquid nitrogen. Um,
Well,
like,
let's to be accurate, it's not liquid nitrogen; it's a vitrification fluid, sort of.
who is it? I see. Yeah, yeah, yeah.
Yeah, so there it's called the process of vitrification, where you put special fluids down the blood, and it basically becomes like a glass
I
object.
see.
It locks everything in place, it
Sorry, I
stops
see.
entropy,
Yeah,
and you're preserved at sort of like
yeah,
almost
yeah,
zero
yeah.
Kelvin or minus
Yeah, yeah,
270 some
yeah,
degrees.
yes. No, I disapprove of people doing that. I think it's selfish and unethical, because first of all, it's probably a waste of money. Then never happen. But if they were revived, then they'd be revived into a world where they are sort of refugees, strangers, etc., and they're putting a burden on future generations. Now, if someone is expelled from the Amazonian forest and they come here, we feel an obligation to look after them. Or if people are refugees, we do. But if they are refugees from the past, as it were, then they're imposing an obligation, which they'd be completely out of place in the world where they're revived.
Well,
Um,
the idea is that you would be able to catch up on the time that you lost very quickly with the new sort of neural implants and enhanced learning methods, and sort of you can simply download the the time lapse that you had while you were in cryo sleep, and then basically be up to date very shortly after you wake up.
but this raises the question of whether that is still you. I mean, there's a whole controversy among philosophers about
Yeah,
if your brain is downloaded,
yeah.
um, uh, is it really you? Are you then happy if your body is destroyed? And what happens if many copies are made of you? Which one is you? And so I think it's not at all clear whether um, this would be you if you're so hugely enhanced. So, and if it's not you, then what's the point?
Yeah.
So I just think it's crazy that people should do this, and I would say that it's unethical, just like it would be unethical to clone a Neanderthal.
Well, we already have, in some ways, people who have been preserved in cryonics. Only they were embryos when they were preserved, and now they're walking around.
Yes, yes.
Right. So we had embryos that were inseminated artificially, stored for a particular period of
Yes, yes.
time
Yeah.
in deep freeze, and then basically implanted, and there were healthy children that came out from those.
Yes, yes. But that's talking about 10 years or so, isn't it?
Yeah, it's of course it's a
Yeah.
relatively new
But,
technology that's
but,
been around for a few decades only. Yeah.
yes, yes. But
Uh,
there's a difference if human beings have themselves changed. Then you wouldn't have an embryo which is like we are, that would be happy in a world where human beings have changed.
Let me bring in another question here. Michael Nushke asked two questions. The first one was about technological unemployment, and I think he can find the answer within our discussion that we already had. But the second one is a continuation on that topic, and it's this. What if AI advances achieve emotional intelligence and surpass what we think are human-only jobs within 10 years? So, for example, some of those jobs that you're talking about, like personal attendant for aging people and stuff like that. And what if a robot in 10 or 15 or 20 years is able to do as good or better job because they're able to develop empathy and emotional attachment to human beings?
Well, I mean, I don't think that's realistic because we want to be cared by someone like us. If they're more intelligent, that's not relevant. If you're being cared, you want someone who shares your human emotions, and so the more like you they are, the better. I think so. So I think we'd always want to have a human being in those connections when we're dying or something like that. But it certainly is possible that these machines will have human capabilities, and that's, I think, as I said earlier, important to how we react to the takeover by post-humans. If they do have these emotions and this consciousness, then it's something which I think we should welcome. We may be a bit chauvinistic being humans, but we should welcome it. Whereas if in fact one could somehow show that they don't have any inner life or consciousness, then I think it would change our attitude towards that scenario.
So how do we evaluate that? Do you think the Turing test would be any good?
I don't think it is, no, because you can this is what's called a deep problem of consciousness, and I don't think the Turing test does settle that. And some people say it's not a real question. It's like asking, does a submarine swim, which is a sort of semantic question and doesn't matter. But I think it does matter, and perhaps we'll answer the question one day. But I think the important point I would make is that we should remember just how different all these timescales are. The timescale for biological evolution is millions of years. Timescale for technological change is hundreds of years, or even just decades. So if we think of the future, then these technological changes will happen in a timescale of a century or less, whereas the time available is 6 billion years for the sun, and of course the universe, as you were saying earlier, could be far longer. So we just can't conceive of what could happen on time scales. The entity is quite different from us.
Martin, we've been talking for about 90 minutes now, so let me ask you my two last questions.
Yeah.
First of all, what's the best place for people to find more about you and your work?
Well, I should say that apart from the two books you mentioned, I've written several books on astronomy and space. There's one called Our Cosmic Habitat, one called Just Six Numbers, and my first book called Before the Beginning. And these are, in some respects, out of date, but I would say that Our Cosmic Habitat and Just Six Numbers are not particularly out of date. So I would hope that if people enjoyed my book on the future, they might enjoy those other books as well.
Yeah, and they can be pertinent to some of those questions that we touched upon during our conversation.
Yes, and of course, there's a lot of stuff on the web from other interviews and talks. It's rather frightening how much of one's stuff appears on the web. And if you give a talk at a university, it now does appear on the web.
Well, Martin, what do you want your parting message to be with you today? We've been discussing your latest book and a number of other relevant issues for 90 minutes. What's the most important thing that our audience should walk away with from you today?
Well, I think they should understand how wonderful it is to have some feeling for science, because I've been involved in one particular area of science, and we've learnt in the last 30 or 40 years about the beginning of the universe, that there are billions of planets like the Earth in the universe. There may be life out there. The universe is now more wonderful than we thought it was. And even something as simple as an insect is amazingly complicated. Just think of all the chemical reactions every time a fly flaps its wings. It's quite amazing. So I think one should be aware of the wonder and mystery of the universe, as well as being gratified that we've understood so much. But I think more generally, I think as human beings, we are limited in our perceptions and in our lifespans, obviously. But we need to think on a slightly longer time span. It's very sad that we can't plan 100 years ahead. We don't build cathedrals anymore, as it were, and we don't plan in a way that will ensure that the world at the end of a century is not a depleted world. We don't want to leave for our descendants a world with mass extinctions and a depleted world and more dangers. So we need to think that far ahead. At the time we're speaking, there's been some discussion in Britain about demonstrations by school kids on climate and issues like that. And I think this is welcome, because those who are still at school now are likely, without life extension, to live to the end of a century, and they care about what's going to happen to the climate and how technology is going to be used and how it's going to be developed. And so I think we should take notice of what they say and their concerns, and redouble our efforts to make sure that all the wonderful technology we're developing is going to be used for human benefit, and do all we can to avoid the serious downsides, because it empowers us more for good and for ill. And that's the main theme of my book, that the stakes are higher now than they ever were before.
Mm-hmm. And my favorite quote, I think, or it's not a quote exactly, it's a slight paraphrase from you from the book, is that we need to think globally, rationally, and long-term, empowered by the 21st century technology, but guided by values that science alone cannot provide.
Yes. Yeah.
So that's why I've been trying to sort of bring and bridge this conversation between the scientists and the philosophers and the politicians in some cases, and bring all those issues together, because in that kind of a mixture, sort of, we can cook our future with sort of a sprinkle of science, a sprinkle of ethics, and we can sort of come up with a tasty, delicious future for all of us, rather than, you know, just a single ingredient, which in most cases would fail, in my opinion.
Mm-hmm. Well, it's been very good to talk with you. So thank you very much for your time.
Thank you, Sir Martin Rees. I really appreciate you coming to speak with us on Singularity FM.
Thank you very much indeed.
If If you guys enjoy this show, you can help me make it better in a couple of ways. You can go and write a review on iTunes, or you can simply make a donation.